Okay, so looking at a homework problem from 4.4 in our textbook, it says find the value of the constant a, b, and c so that the graph y equals ax cubed plus bx squared plus cx has a local maximum at x equals 1, a local minimum at x equals -3, and an inflection point at -1, -11. Okay, so let's look at this. I know that to find out where my local max and local mins are, I would be looking at my first derivative. And so I know that if this is a local max here, right, this would be something that's increasing until I get to x equals -1 and then decreasing. And then at x equals, so this would happen at x equals 1. To have a minimum at -3, that means that it was decreasing. And then in between these values, it's increasing. Okay, so we know some things about this. We also know that these values where we have a max and a min, that's when our first derivative was equal to 0. So we know what those x values are. And that set the derivative equal to 0. So let's go first and look at the derivative of y. So y prime, or dy dx, is another way to state that. Derivative of ax cubed. A is just a coefficient. And so a derivative of x cubed is 3x squared. So that 3 times the a. So we're going to write this as 3ax squared plus the derivative of bx squared. So that's going to give me 2bx plus the derivative of cx. So that is c. So we know 3ax squared plus 2bx plus c is equal to 0 when x equals 1 and when x equals -3. So let's rewrite this. We have actually 2 equations here. So let's go back in and let's plug in 1 wherever we see an x. And so if we do that, we get 3a times 1 squared. So that just gives us 3a plus, if I plug in 1 for x for the second term, 2b times 1 is just 2b. Plus, there's no x here, so c is equal to 0. So there's one equation. Now let's go in. This time it's a little harder, but let me go in and plug in -3 wherever I see an x. So doing that, we have 3a, I see an x there, I'm going to square -3 plus 2b, I see an x there, we're going to plug in -3 plus c equals 0. So cleaning up this equation a little bit, I have -3 quantity squared is 9 times this 3 out front. 9 times 3 is 27. I'm just going to write it underneath this because I'm going to get a system of equations here. So I have 27a. I have 2b times -3, that's minus 6b plus c equals 0. I'm going to get one more equation because I'm also told that I have an inflection point. And I have an inflection point at -1 and -11. And so if I'm getting that, then I know, what do I know? I know that when x is -1, my y value is -11. So I actually don't even have to go to the second derivative here because my inflection point is occurring. I can plug this into my original equation. -1 is where my second derivative was equal to 0. If it's an inflection point, it's changing concavity there, but I would plug that back into my original equation to get that y value. And so let's look at that. So this is saying that x is -11. I'm sorry, not x, y is -11. So I have -11 is equal to a times x X in this case is -1 cubed plus B times X, which is -1 squared, plus C times X. X in here is -1. So before it was the first derivative, this one I'm plugging into the original. So this gives me -11 equals, well, -1 quantity cubed is -1 times A. So this is -A plus -1 squared is 1 times B is B minus C. So I'm going to rewrite it so my variables are on the left and my constant is on the right of the equal sign. So I can rewrite this as -11. Sorry, no. Just stated I wasn't going to do that. So this is -A plus B minus C is equal to -11. Okay, so we have a system of equations. We have 3 variables, 3 unknowns. And so there's different ways to approach this. I personally would prefer to do matrices, if you guys are okay with matrices. If I was doing matrices, so there's a couple things that we can do to have equivalent solutions at the end of our system. We can swap our equations around. We can multiply a equation by a non-zero number, and we can sum an equation with a sum of another equation multiplied by a non-zero constant. So I would swap, and our goal is to get the, if you don't remember, just really briefly, with matrices, our goal was to get that ones in the main diagonal and zeros above and below, and whatever our numbers were in here, I don't know, I don't want to call them A, B, and C because I'm not sure. But this could be, actually, this would be A. That would be our value of A. This would be our value of B, and this would be our value of C. Okay, so I would, and you always work column to column. If you didn't want to do this, you would use the elimination method. And you would get 2 of the equations with 2 of the same variables and break it down that way. I would rewrite this so that my first equation is in my first row. So I'm swapping these 2 rows. So I'm going to swap, and I call them row 1 and row 3. Row 1 with row 3. Remember, with matrices, we don't put in our variables. We're just writing the coefficients down. So we have -1 here, 1, -1, -11. Second equation, I'm not changing. It's staying the same. So just writing the coefficients, 27, -6, 1, 0. And my new row 3 is 3, 2, 1, 0. So I always use my 1. I'm going to leave it as a negative for now. And then we can multiply row 1 by a -1 in a second. But let's use row 1 to get rid of the 27 below. So I know I would have to multiply my row 1 by 27. So 27 row 1 plus row 2. So I'm technically not changing my row 1, so I'm going to rewrite it, -1, 1, -1, -11. But I'm using it to get rid and make this a 0. So -1 times 27 is 27, -27, plus this 27 below is 0. 27 times this one is 27, minus the 6 gives you 21. -1 times 27 is -27, -27 plus 1, that's -26. Yikes, -11 times 27. I don't know if this is the easier way to do it or not. So 11 times 27, that gives us 297. That's going to be negative 297. I want to get rid of this 3 down here in this third row. And so I'm going to use row 1. Think about what's going to multiply this -1 by to give me an opposite sign of 3. So I want just 3 row 1 plus row 3. So I have 3 times row 1, -3 plus 3 is 0. 3 times 1 is 3, plus 2 is 5. 3 times -1 is -3. -3 plus 1 is -2. 3 times -11 is -33 plus 0 is -33. We really want this to be a positive 1 up here. So let's do that by just multiplying -1 times row 1. So that's the only row that's changing. And so just multiply every single term in row 1 by a -1. So that would give me a 1, -1, +1, 11. Let's, as we're doing this, I need a 1 right here. One way I can do it is divide everything through by 21, but that just like makes me really scared to do because then I'm dealing with all these nasty fractions. So I want to manipulate it if I can without dividing that whole row by 21. I notice that 5 times 4 is 20. So if I use this row down here in row 3, so if I did -4 row 3, that gives me -20. Let's do -4 row 3 plus my row 2. So if I did -4 times 0, that's 0. 0 plus 0 is 0. -4 times this 5 is -20 plus this 21 gives me my 1 that I wanted. -4 times this -2 is 8. So -26 plus 8. I know I can do this in my head, but so that's -18. That's going to be -18. And then -4 this times this -33. So 4 times 33. 2 negatives make a positive. So that's 132 minus 297. So that gives me -165. I was just using my row 3 to get the row 2 how I want it. So I'm going to rewrite row 3 down there. So 0, 5, -2, -33. Okay, so I have the one where I want it. I always use that 1 in the column that I'm working on to get rid of the numbers above and below. So notice if we add row 2 to row 1, this -1 would make it a 0, which we want. So we're going to now take row 2 plus row 1. I'm using row 2, so I'm going to go back in here and I'm just going to rewrite row 2 because this is going to stay the same. I'm just using it to manipulate what I want. Okay, so row 2, 0 plus this 1 is 1. Row 2, 1 minus 1 is 0. -18 plus this 1 up here, that's -17. -165 plus 11. So that's going to be -154. So now I want to get rid of this 5 down in here. So I know I can multiply -5 times row 1. So not row one, row two, plus row three. So 0 times anything is 0, plus this 0 is 0. -5 times 1 is -5, plus 5 is 0. -5 times -18. That's going to be positive 90. 90 minus this 2 is 88. So -5 times this -165. That's positive 825 minus 33, which is 792. Okay. Thank goodness 792 is divisible by 88. So what we want to do now, we want a 1 down here in the third row, third column. So let's multiply this, let's multiply this third row by 1 over 88 times row 3. So doing that, well, 1 over 88 times 0 is 0, 1 over 88 times 0 is 0, 1 over 88 times 88 is 1, and 792 times 1 over 88 is 9. Rewrite all the other rows in here. Okay, so we're going to use this one to get rid of the entries above this. So if I do 17 times row 3 and add it to row 1, I would get this 0 up here. My row 3 is staying the same. I'm just using it to manipulate the other ones. Okay, so 17 times 0 is 0 plus 1 is 1. 0 times anything is 0 plus 0 is 0. 1 times 17 is 17 minus 17 is 0. 17 times 9. That's 153. And 153 minus 154 is -1. Now we want to get rid of this -18. So if I do 18 times row 3 plus row 2. So I get 0 here. I still have my 1 here. 18 times 1 is 18 minus 18 is 0. 18 times 9. That's 162. 162 minus 165. That's -3. This column was my A, this column was my B, this column was my C. So I know that A is equal to -1, because this is saying 1A plus 0B plus 0C equals -1. I have B is equal to -3, and I have C is equal to 9. So what did I say? -1, negative. Now it's all frozen. Not frozen, but. Okay, so just plugging it into the program, we saw that that was correct.